Well, hi, good morning. Welcome to my shop. At least it's good morning for me. It may be the evening for you. So I'm going to be doing the alignment on this radio, and perhaps that'll be the last thing, and a couple other smaller issues that have come up, like the light bulb and stuff like that. First, I thought it might be interesting to compare this radio a little bit to another one that's pretty much just like it. So this is one I've had around for quite a while. I fixed up a few months ago. You may have watched videos on this. I didn't take this radio too seriously. The cabinet is fractured terribly and stuff like that. But I think it's interesting to compare them. The radio itself is almost identical, but not. But the front panel here is pretty much all the same deal, pretty much. Bigger wooden cabinet. So this one's called the 5300 and this one's called the 5200. They're both known as Baby Champ radios. So let me take this guy out. Let me take both of these out of here now. Okay. So I've gone over the alignment instructions. It's a simple radio, a simple alignment procedure. IF first, then RF and oscillator afterwards, just like all these radios. But the instructions are pointing to a capacitor that doesn't exist in this radio. And I'm a little surprised. So just to show you, there are two capacitors right on the big tuning capacitor here. Two trimmers down here. Yeah, you can see the screws for them. There's a trimmer hidden underneath, right up here. It's a little bit unusual. You can only get to that when the radio's out of the chassis. But the trimmer that it points to as another one is down in here. On the, can you see that there's nothing down there? There's no screw down there. So I'm not quite sure what that's all about. Another difference between the 52 I was showing you and the 5200 and the 5300 here is this capacitor here. So if we look at the under chassis photograph, which I probably will not bother putting up right now, for the 5200 there's a large capacitor right in here, and you can see this opening is smaller and triangular here. In this radio, this is much larger. It's a square opening in it, and the big capacitor's missing in action. Unless you assume the last guy removed it and replaced it with these, which I don't think that's what happened. What happened was it's a revision to the radio. They put in a 4-section capacitor instead of a 3-section capacitor and didn't need the extra one here anymore. That's probably saved 6 cents a radio. Big money. So that's in terms of doing an alignment, when the radio doesn't quite match the instructions, I think it's pretty straightforward how to do this anyway. I'm not so sure instructions are necessary. The IF frequency is 455. So we're going to get set up to do that. But first, let's deal with this light bulb thing. So the light bulb I pulled out of it is a 44. So it's a little bit critical. This isn't just being fed by a transformer, right? It's being fed as a tap off from the filament in the rectifier tube. I guess that's the best way to put it. The amount of current that flows through this bulb is critical for the operation of the radio. Well, critical might be a strong word. It's worth thinking a little bit. Now this bulb, I believe, is double the wattage of a 47. It double the current. I'd have to look in the book, but let's guess. It's a 1/4 amp, whereas the 47 is 150 milliamps. So this radio is going to put through this bulb what it's going to put through this bulb. This really isn't a power supply type situation. So I think this guy was starved of current from what he really wanted, making him dull. So that's my thinking on that. You can read a lot about how lights are operated in these 5-tube radios. I'm not going to try to explain it in detail. It's a little bit complicated and kind of interesting. To some degree, a bulb like this can work as a fuse. To some degree. So read up and learn for yourself. I've got to have the bulb in there too. I shouldn't operate this radio with no bulb. So I'm going to fish out a 47 here, and we'll pop it in there. So I'm getting everything set up and ready to go. I've got my signal generator over here ready. Not quite ready, actually. It's at 10 megahertz. So we want this at 455. There we go. 455. Okay, now I've made a connection to this meter. This meter is going to monitor the AVC voltage, and I picked it off in an appropriate place. I hope I got one lead on the negative of the power supply in here, not on the chassis, but on the power supply negative, and the other one is on the volume control at the point where it's receiving the output from the did I get that right? I think so. I think so. Well, we'll find out soon enough, that's for sure. Okay, so that's going to read the AVC voltage, and that's what we'll be using to judge the alignment here. I'm going to flip this back this way. I guess we're not going to be able to get at that. Well, we're doing the IF first, so there we are. Okay. These are the two IF cans. I'm pretty sure this is the second, this is the first. You notice this one is insulated from the chassis, but this one is not. He says, okay, all that would be probably in order to prevent noise or something like that. Well, okay, not sure. Lots of stuff to not be sure about. You know, there's a lot of stuff to know about these radios, and every time I go to work on one, I learn something new, so okay. Silence. I think I'm ready. Okay, volume down. Tuning just in the middle for now. Dim lights. Are we ready on the dim lights here? Okay, this one just glowed ever so faintly, just as it should have. Here's the IF coming through already. That's because I got it up on a very high level there. Turn it down. The signal from the signal generator is being injected with these wires right into the antenna wire that goes to the capacitor, and that's as per the instructions. We're on the 1 volt scale, so it's 1 volt at the top here, 0.1 volts at the bottom. We'll tune the radio and see if this moves. By the way, I can't tune the radio. I gotta tune the signal generator here. Oh, you can't see the meter. There we are. Everything all ready to go. What's up? What's up with you here? Okay, caught on a wire. Happens a lot in here. Okay, standing on another wire. Too many wires. Now I watch this meter. See if it doesn't change. I'm getting a very negative reading there. I shouldn't say negative. It's not negative. On this meter, this is not zero. There's no zero. It never reaches zero. Well, there we are anyway. Where's the peak? Seems to be quite broadly tuned. I would say that's the peak. And what's the number? 456. So it's pretty darn close. So anyway, conclude the guy who worked on this last took care of this. So let me set this to where it should be, just below that. About there. Now we're going to tune up, maximize this. There we go. Down. What happened there? What's happening there? tube in the tube socket. So I grab this and I grab that. Shame, 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 Jim. Sure looks like it's something to do here. Oh. No. Tube. Okay, just 1 second so we don't have to listen to it too much. I'm going to assume it's just a tube pin contact problem. Goes down quite a ways before it grabs. Okay, back on. So it could be a cold solder joint underneath here. We'll go hunting for that if that's this hasn't straightened it up here. Yeah. Wow. Let's take a look. Let's just take a look under here for a minute. This tube here. So we're talking about way down in here. So first thing I'm looking for is any work that's been done down here, and I don't see any work. So chance of a cold solder joint really low. Could still be there, but certainly all looks fine. Can be when you move this tube a little bit and it causes that noise. It's because the motion is being transferred through the components over to another spot. So we should look at the other side of all these components here. But again, I just don't see that, you know. I don't see any obvious. I don't see any obvious cause for that. Wires aren't involved here. Okay. Well, so looking down on the socket, everything looks normal, and of course the tube looks great. This tube looks great. Try it again. Took a few moments last night and cleaned this thing up, cleaned up this, cleaned up the knobs, cleaned the dust off the tubes here. So, oh, for crying out loud. Okay, let's try it for real. So that sounds like what's happening is the slider is leaving the end of the runway and just moving off onto the Good enough though. Okay, a little lower on the signal strength here, I think. That's a little better. Now we'll try. Okay, that seems to be gone. Watch the meter again. Wait a minute, 4. Yep, we're on the right frequency. Away we go. Yeah, this is pretty well aligned. Oh, okay, so that changed the tone a lot. Got a little bit there. I think the control is losing contact, and that little pop is a discharge of something when something like that. Anyway, okay, that's good. IF done. Okay, I'm under pressure now to get this done. I've got cats that want to go outside. I got to be out there with them. Okay, so we've got the signal generator set to 1400. Can you kind of read it there? 1399. That's a pretty low signal doing that. That's very good. That's very, very good. So we want to know if this is right on 14. No, it's not. It's not right on 14. Let me try this with a different camera here. See how that does. Okay, let's get rid of the parallax. So it should be coming in here. Well, I don't hear anything. I will now adjust the oscillator trimmer. I'm pretty sure it's this one here. Maybe not. Okay, so what I'm going to do, the radio is set to 1400. I'm going to tune the signal generator, find out where it actually is. Where is it? Wow, okay, 13. So we want this to be 14, so I'm going to turn it up, past, till it fades out. I'm going to give it a little more juice here. That's a lot more juice. You can hear it a little higher. There. You can hear that. So I will now chase that. That way I'll know I'm turning this screw the right way. Provided I can get my screwdriver into it. There. Louder. Okay, so that goes louder this way. So this is the way to turn it. Turn it a fair bit here. Okay, let's see where we are now. Oh, I pretty much hit it dead on. Okay. A little loud on my ears. There's that pop again with the volume control. Okay, so that's about the peak, and in fact we're tuned to, check it out, 1400. And on the dial, 1400. Excellent. Now we go down to the other end of the dial. Here. Go down to where? Probably around 600 here. Let me just take a peek and just make sure. They like it 600. And then I'm doing the what they call the oscillator lag trimmer, which is the one underneath the radio. Oh, what are you looking at there? Sorry about that. Okay, let's get back to what's happening here. Right. So 600. Okay, so I've got it on 600, and we'll tune the signal generator to 600. So that's the IF leaking through. There's the 600, pretty darn close. I think we can bet, that's close enough. In fact, that's really quite close there. Make it a little easier to see the numbers, a little bit. So there we are, 600 where 600 should be. There's no reason for me to make another adjustment. So that's the oscillator. Now there's an antenna adjustment I still need to make, and the antenna adjustment is done on, it has to be the other trimmer on the big capacitor. So where should we do that? 14, or do we do that? We do that at 14. Okay, so we want this tuned really, really accurately. Use the shop lighting here. There, bring this into view. There's a little piece of wire there that I'm going to bump. Go. Okay, now watching carefully this meter. Down, up. Oops, I slipped out here. Up, up. I'm tightening it here. Up, up. It's just about as tight as it'll go. And it's going down again, so pretty tight. There's a peak in it. Okay, let's see what we got now for a radio. So we'll cut this off. Put that right there. Still hooked up here, but that shouldn't affect the radio at all. Don't usually pick anything up until you get down around here. During the day here. Might get a French station in here if the radio's working well. Get a station right here at 680, 640. 590. I think it's all because the antenna is tipped the wrong way. Okay, so let's go 90 degrees. So the impression I'm getting here is that with loud signals, something is being driven into a cutoff state like a tube. Well, this could be because of some kind of incorrect biasing that's occurring in the radio, or a tube that's in bad shape, or it could be that volume control I put in has disturbed a little more than what I would want. Maybe it's changed some of the biasing levels in the radio. So it's working, it's tuned up. Okay, so I've got this meter back here hooked up to the AVC. Perhaps that's throwing it off. Let's get it out of there. So it can't be. Just in case. Back on. I think that made a big difference. Oh, maybe not. Well, the next step with this radio, if I'm going to go further with it, would be to test the tubes and to make sure the tubes are working properly in it. It could be a weak tube is causing this. Another possibility is the AVC voltage is not operating properly, again maybe because I stuck this volume control in here. So I'm going to stop at this point for today. I'm going to think a bit about it. This isn't the most valuable radio in the world either, and how much more effort do I want to put into it depends what comes in the mail today. If today some parts show up, I'll go back to that great big radio I was working on. No parts, work more on this guy. So thanks a lot for watching, and we'll see you on the next video.